Okay, so hello Sharad, the recording has started. Uh, I'm going to project the screen now and discuss the assignment number.
Okay, sir.
Right, you want to say something, Sharad? Hello, do you want to say something, Sharad? Okay, it seems that.
Nothing, sir.
Okay, that's good. Uh, so let me start the presentation. So I hope you can see the screen, right? So, so this is the first question of assignment number 5. Uh, it asks you to find the Thevenin equivalent across the terminal AB. So this particular assignment is all about the equivalent circuit diagram of Thevenin's and Norton's equivalents, right? So the first question is around the same. Uh, so tell me, Sharad, is this circuit possible in the first place? Like, is there something which is not correct in the circuit, or everything is correct in the circuit, Sharad?
Sir, the current direction in same branch is opposite to each other.
Not
That is
possible,
possible, not possible.
right? So you are correct, Sharad.
Yes, sir.
So this is incorrect diagram of circuit, right? Because as you rightly pointed out, these two current sources are opposite to each other and different in magnitude, which is not possible. So because of which none of the above is the correct answer, and that's the solution of this particular first question. Okay, so let us move to the second one. So the second question is asking you to determine the value of current flowing in a resistance R when it is equals to 6 ohm, right? And it is given that the current in resistance R is equals to 4 ampere when resistance is equals to 0 and 2 ampere when resistance is equals to 2 ohms, right? So 4 ampere resistance 0, 2 amperes resistance 2 ohm. And this is all the information which is given to you, right? So let me ask you, Sharad, what's the value of the resistance of the this ammeter? Is there some resistance in the ammeter, or is the resistance equals to some zero value?
Normally, it's minimum resistance should be
Correct.
there.
So we will assume here the ideal situation. So in ideal situation, the ammeter is zero resistance device, right? So the only resistance present in the circuit is this resistance R, which is unknown to us, and it's changing, right? So how to go forward here, Sharad? So one can approach this question in two manners, Norton's or via Thevenin's, right? So let us see one by one. So one, two. So if this is my I source and this is my I equivalent, let me call it RTH, and this is my resistance R, which here is equals to 0 in the first case. So if R is equals to 0, whatever the value of I, the same value will be flowing in here, right? Because this will be the least resistance path, right? So if the current here is 4 amperes, it's mentioned to you. That means that the current source value is equals to 4 ampere. Agreed, Sharat?
Agree.
So in the second case, if 4 ampere current is flowing over here, right? And it's given to you in the question that resistance is equals to 2 ohm and the current is equals to 2 ampere. That implies that this thing must be followed, right? That is 4 ampere multiplied by the resistance RTH upon RTH plus 2. This must be equal to 2. Agreed, Sharad? Current division.
Yes, sir.
So this will give you the value of uh, RTH as 2. RTH is equals to 2, right?
Yes.
Now, if RTH is equals to 2, that implies that in the third scenario, when the question is asking you uh, what is the current flowing if this R is equals to 6 ohms now, right? Then you can figure out the current, right? It will be 2 divided by 2 plus 6 into 4. Now this is equals to what? Tell me. This is equals to 1, right? Right,
Yes.
Sharat?
Yes, sir.
So that will give you 1 as the correct answer, and that's the correct answer. So this is via the Norton's theorem. And by Thevenin's theorem also you can figure out. So in Thevenin's theorem, what you will do is you will assume the V Thevenins as V Thevenins, and then you will assume this is RTH, and this will become your R, right? Unknown value. So in case 1, R is equals to 0, so you will have equation as V Thevenin by RTH. This will become 4 ampere, so equation number 1. In equation number 2, you will have R as value as 2 ohms, right? So in that situation, it will be VRTH plus 2 is equals to uh, is equals to uh,
I get
2 ampere. So this will become equation number 2. So you have two equations and two variables. You can solve them and then kind of figure out uh, the same answer that you got via this. So there is not there is not nothing much in that. Like even if you don't know Thevenin's and Norton's, you can just assume the voltage and then the resistance in path, right? Equivalent resistance in path, and then kind of solve this. But the moment you are saying equivalent resistance, you are indirectly going towards either Norton or Thevenin. So that's why you are invoking the concept of Thevenin's and Norton. Uh, I hope you did understand this particular solution, right, Sharat?
Yes, sir. Yes, sir. Yes, sir.
Okay, good. So, uh, in this particular, okay, so somebody else has joined. So, in question number 3, it's required, just let me see if it is recording is ongoing or not. Okay, it's recording, not a issue. Take it. So in this question, it is asked to determine the maximum power dissipated in the resistance RL. Okay. So let me step back and then just ask you guys, if you have a voltage source V, if you have some resistance R, and you have some load resistance RL, then at what value of RL would you have the maximum power dissipation in RL? So power dissipation in RL is is maximum at what value of RL? This is what I am asking to both of you. Like any of you can unmute yourself and answer this question. Like take a guess. Okay, Satish has left this call. Sharad, do you want to take a guess here?
No, sir. Please, guys.
Okay, so the dissipation of power is maximum when RL is equals to R. Okay, so This is something which you will be covering in your first year engineering electrical. Now, why this is so? So, uh, you can write the current equation as V divided by R plus RL, right? And you know that power dissipation is nothing but I square into RL. Therefore, you can write that power dissipation is V R plus RL whole square into RL, right? Now, if power dissipation is maximum, then you can write dP upon d differential of power with respect to RL is going to be uh, equals to 0, right? So you take a differential of this and then equate it to 0, and then you will figure out the solution of RL. What's the solution of RL in terms of R? So that will give you a value of RL is equals to R, and that is how you figure things out, right? So this is the condition of a maxima or a minima, right? You take the double differential and then you will understand whether it's a maxima or a minima, right? Uh, so this is how you proceed. I'm hoping that this is something which you will be covering in your undergraduate years, right? So I'm not going there, but then I'm just taking the final result and then I'm utilizing the same year. So the final result says that the power dissipation will be maximum when RL is equals to the overall effective resistance, right? So when you're saying effective resistance in this particular circuit, you are implying towards the equivalent Thevenin's resistance, right, Sharad?
Right, right, sir.
Right. So, okay, someone else has joined. So, how do you figure out the power in this particular case? So, there is two objectives which you must cover. First is the determination of what is V Thevenin, right? Because you would be requiring it in determination of power, right? So, I said
Right.
that power is nothing but I square R, right? Also, you can write it as V Thevenin's divided by R Thevenin square into R Thevenin, right? So
Yeah.
if you want to figure out power, you have to have a value of V Thevenin. That is first thing. Second thing is that you have to have a value of R Thevenin. That is the second thing. Once you have these two things, you can determine the value of the power. So for determining the same, let's go for V Thevenin's calculation, right? So what do you do for VThevenin's? What you do is you will just open circuit this particular thing, right? And then this particular RL is now open circuit. Now you determine what is the voltage across these two nodes, right? So for determining the same, let me just ground it. It would be a little easier. And then let me just take this voltage as V, voltage V, right? And apply KCL at this particular node. Let me call this node as node A, right? Let me call this node as node B. So at node A, if you will see, uh, and this particular voltage at potential at B is nothing but 5 volt uh, plus voltage V1, right? Is the voltage at potential B is at B. That is that is one thing which I have got. And also V1 is the drop. V1 is the drop in the 3 ohm resistance, right? Now let's write the KCL at node A, right? So at node A, the KCL will be equal to
0.5 V1.
no, current flowing from this side plus current flowing from this side is current flowing here, right? So you are saying that zero point 0.5 V1, right? Go ahead.
Equal to VA divided by 2 plus
Okay, V divided by 2, and then
minus VA VA minus VB divided by 1.
Correct. So what is VA? You don't know. And what is VB? You know from here,
VB,
right?
VB equal to 5 plus V1.
Right, correct. So this is correct thing which you have mentioned. Okay, okay, where did it go? Yes, this is the correct expression which you have mentioned. So this is 0.5 V1, and then you are taking it equal to here, right? So I can take since the current direction I've taken here like this, I'll just take it like this. So it will be VB minus VA divided by 1 ohm, right? But I know the value of VB as 5 plus V1, right? So I can
Right.
just write 0.5 V1 plus 5 minus or plus V1 minus V, right? Because VA is nothing but voltage V, right?
Right.
And this divided by 1 is 1, and then this is V by 2, correct? So this
Correct.
is the equation which you have got. Uh, Now, tell me one more thing that uh, the voltage, just 1 minute, voltage, we have to determine the voltage V, right? And I need one more equation. So I can write, okay, so 5 minus voltage V divided by 4 is the current, and then that multiplied by 3 ohm is the voltage V1. Correct?
Correct. Correct.
Uh, of course, this will be a negative sign will be there because uh, you are taking IR drop, right? So you are taking the current to be like this. So negative sign will come, right?
Right, sir.
Okay. Current is flowing like this. So in the direction of current, there will be a drop. So yeah, so this is the correct expression. And now you can put this in this particular equation. Uh, point. Okay. So what do I want? I want V1, right? Because if I have V1, then I can know what is the Thevenin's voltage across this, right? So I'll just substitute V in terms of V1 from this particular equation. So I have 5 plus V1 minus 1. Okay, 5 plus V1 5 plus 1.5 V1 minus V minus V, minus V, I'll take it that side. So it will become 1.5 V, and V is nothing but uh, minus 4 V1 by 3. And okay, please mute yourself. I think lots of noise is coming from your end. Minus 4 V by 3 uh, and plus 5 and whole minus sign, right? I'm just substituting this particular thing over here, right? So once you substitute that, you will have to solve for V1, right? If you'll solve for V1, I have solved it, therefore I'm no, I'm aware of it. If you'll solve it, you will find that V1 is nothing but equal to minus 5. Right? If you solve this particular equation, you will get the value of V1, and you will figure out that V1 is nothing but minus 5. And if you will put that particular minus 5 in this particular equation, equation number 1, you will get the value of VB to be equal to 0. So if value of VB is equal to 0, that implies that the Thevenin's voltage across this particular resistance is equals to 0. And therefore, like you don't need to go to step number two, that is a determination of Thevenin's resistance. Because if the Thevenin's voltage is equals to zero, then the power loss in the resistance will be equal to zero, and that will be the answer. So, so that is what would be happening in this particular circuit. Like the Thevenin's voltage across this particular resistance will be equal to zero, which will give you the answer as none of these. So, did you understand this particular solution? So there are two people over here, Abrar and Sharad. Did you understand the solution? Both of you?
Yes, sir. Yes, sir.
How about you, Abrar? Did you understand it?
Yes, sir. Yes, sir.
Okay. So it's a question, like the next question is based on the same on the same concept of determination of power. So the RL, you have to figure out the maximum power that can be transferred to RL. So RL must be equals to R Thevenins, right? So how to figure it out? So here, what you need to do is like you need to figure out what is the V Thevenin, what is the R Thevenin, and then after that you can figure things out, right? So just like in the previous case, we'll proceed. So here you have got a dependent current source, right? So we'll make use of it. Like previously we have solved for V Thevenins, right? And then we found out to be equal to 0, and therefore we did not have to calculate the R Thevenins in the previous case, right? Now, for the just sake of like, I have not calculated the R Thevenins in the previous questions, right? Let's just for the sake of calculating R Thevenin, let's proceed with this particular calculation first. So, how do you calculate Thevenin's equivalent resistance, right? So what you do is, if there is any voltage source which is present in the circuit, you will just short it out to 0. If there is any current source which is present in the circuit, you will open circuit the current source and will make it open source. If there are any dependent voltage source or current source in the circuit, right? If there are any dependent voltage source or current source in the circuit, you will leave it unaltered. Understood? So here, tell me which is the dependent current or voltage source. Any of you can tell me, like which is the independent source here?
3V. Yes.
3 ampere, correct? So this is the independent current source. And what is a dependent voltage source? Dependent current source.
3V. Yes.
Okay, so this is the dependent current source, right? So it is voltage dependent current source, and this is the independent current source, right? So what you got to do is you need to open circuit this particular element, right? So when you open circuit this particular element, what it becomes? It becomes something like this. Correct? Correct? So you have
Okay.
open circuit this. And now you
Right.
need to figure out what is the equivalent impedance of this particular system, right? Across the point A and B, है ना? So this is 1 ohm, this is 1 ohm, this is 2 ohm, this is 2 ohm, and this is 3 V naught. So are you guys understanding what I'm doing?
Yes, yes.
Good. So you need to figure out the equivalent resistance when looking from this side. So how do you do that? The simplest idea can be like you have a voltage source, so you cannot directly use the like a series and parallel connection. So what you can do is like you can put a voltage source over here, right? 1 volt, right? And then you can find the current which is flowing out. So the resistance, effective resistance will be equal to 1 volt divided by the current, I current. So you need to figure out what is the current I which will flow out, and then based on that, you can figure out the effective value of R threshold, right? So that's very straightforward now, right? So how do you do that? You will take the voltage here as voltage. Okay, something happened. Just give me a minute. Something happened to my pen. Yeah. Yeah. So what you will do is you will take this voltage as V, right? And you will write the KCL at node A. Let me call this node as node A. So uh, 1 volt minus voltage V divided by 2 is equal to and plus 3 volt V naught is equal to V divided by 2, right? Also, it's given to me that V divided by 2 into 1 ohm is equals to V naught, correct? From here. So the current is flowing like this, and therefore the current value is equals to this, right? So current into resistance is nothing but voltage, and the polarity is going to remain the same because you are taking from high to low side. Uh, so this is your equation here, and then you can just substitute it in this particular equation, equation number 2. So you substitute 1 in 2. So you will get as 1 minus 1 by 2 is equals to V, right? And minus 3 V naught. What is V naught? V naught is nothing but V by 2, right? So V by 2, right? So this will become half is equals to minus V by 2. So this will give you voltage as minus 1 volt, right? Now, if this voltage is equals to minus 1, then what is the current flowing in this branch? It will be equal to 1 volt minus V divided by 2. But voltage we have calculated it to be minus 1, right? So the current will become 2 divided by 2 is equals to 1 ampere is the current, right? Now, if current is equals to 1 ampere, then the R Thevenin will be equal to 1. We had taken the voltage as 1 volt, right? So 1 divided by the current we have figured out. So the R Thevenin will be equal to 1 ohm. So this is your Thevenin's equivalent resistance, right? Now the Thevenin's voltage, so everybody understood this, right? How to figure out the Thevenin's resistance? You just put a 1 volt source or any volt source in it, and then you figure out the effective current. Then you divide the effective current you divide the voltage by the effective value of current. You figure out the Thevenin's resistance. Uh, is the solution clear till this part?
Yes,
Uh,
okay.
okay, good. Then let me just figure out what is the Thevenin's equivalent voltage. So for Thevenin's equivalent voltage, what you will do is you will open circuit this, right? And this and other things you will keep intact, except for the points at which you want to figure out the equivalent Thevenin's voltage. You will keep the other circuit intact, and you will open that particular load. So this particular thing is now open, and everything remains the same. So the voltage here is V. The voltage here is let me call it V1. Let me call it V2, right? Okay. And how do you figure out what is V1 and V2? You use the KCL and the KVL. Those two things you are having with you, right? So Let me just, for the sake of easiness, let me just ground it, right? So I know that the branch current here is 3 amperes. So the 3 amperes, entire 3 amperes is going to flow in this particular circuit, right? So the 2 ampere, the 2 ohms will have 3 amperes flowing in it. No big deal there. So that is information which you must keep in mind, that this thing is open, this particular branch is open, right? So 3 ampere has to flow in this 2 ohm, right? So just keep it in mind. Now, if 3 ampere is coming from this side, then I can write 3 ampere plus 3 V naught, right, is equals to V1 divided by 2. Sorry, V1 divided by 2, right? And what is the value of V naught here? It's V1 divided by 2 into 1 is equals to V naught. Same thing what we had done previously, right? And now you can substitute V naught in terms of V1, right? So you can write this particular equation. Let me call this 3. Equation number 3 as 3 plus 3 times V naught. What is V naught? V1 by 2, right? And this will be equal to, this is equal to V1 by 2. Okay. Now you can solve this. It's pretty straightforward from here. V1 will come out to be, just give me in a minute, minus 3, right? Tell me if I'm making positive and negative mistakes, right? So I think I'm correct here. So V1 is equals to minus 3. Okay. Now if V1 is equals to minus 3, this is minus 3. And then I'm going opposite direction of current. So this is minus 3 plus 3 ampere into 2 is equals to V2, right? So this is V2, therefore V2 is equals to 3 volt, right? Now if V2 is equals to 3 volt and the RThevenins we have found out to be 1, then the power which can be dissipated will be given by, what will be the power? Tell me, what will be the power? You can write the effective circuit as V Thevenins, R Thevenin and R load, right? Now we have seen that the load power transfer will be maximum when R load is equals to R Thevenin, right? So both of these are equal, correct? So in that case, you can write here that the current I square into R, right? So what is the current? V Thevenin upon both these things are equal. So you can write 4 times R Thevenin square into R Thevenin, correct? So I'm doing nothing, I square into R, but then I value is this. So I square will be this quantity, right? And into R is what? R is R Thevenins now, right? So you just plug it in. So the value of V Thevenins, I have got it as 3 volt. So 3 into 3, 9. And then 4, 1 into 1 is 1. And again 1. So like 9 divided by 4, that is 2.25. Right, 2.25. So this is the answer number B which you are getting, and this is the correct answer. So this is how you proceed. Like the thing to take home from this particular solution is 2 things which you need to remember. Like if you have a circuit in which there are dependent voltage or current source, then you need to be cautious when you are figuring out the equivalent Thevenin's resistance. What you need to do is you can short all the independent voltage source and open up independent current sources, but you have to leave the dependent voltage sources and the dependent current sources. You cannot touch them, right? And then you need to figure out the effective resistance. So this is one thing which you need to keep in mind. Second thing is that the Thevenin voltage you can determine, which is like a thing which you have already been doing, and then you can figure out the power loss, right? So that is the thing which this particular solution is teaching you. Let me go to question number 5. So the previous solution was all of you understood it, right? Anand, did you understand it?
Yes, sir.
Okay, good. Uh, for question number 5, it's the question is asking you to figure out the current which is flowing through the 2 ohm resistance, right? Uh, so again, you can determine, like you can treat this particular element as the Thevenin's element, and then you can figure out the Thevenin's voltage across it and the equivalent Thevenin's resistance looking from this point into this circuit, right? So you can figure out what is the R Thevenin, and then you can figure it out. So the effective circuit, final circuit would look something like this: V Thevenin, R Thevenin, and this will be 2 ohms. Now, if this circuit is given to you and this value and this value is known to you, you can figure out what is the current in this 2 amperes, 2 ohms, right? It will be nothing but the voltage divided by the effective resistance. So if you can figure out what is the Thevenin's voltage and Thevenin's resistance, you are done basically. So how to figure things out? Like, let me start with Thevenin's resistance, equivalent resistance. So who will help me? Anand, since you understood the previous question, just help me write, like redraw the circuit for Thevenin's equivalent resistance. What should I do now? Anand, you can unmute yourself and then speak.
I don't have any idea.
Okay, okay. So if you guys are not understanding, you can say that you are not understanding, right? So there is no point in saying yes and then like not able to respond in the next question. So just let me repeat what I had repeated previously. For determination of RTH, short independent voltage source, right? Open independent current source. Leave dependent voltage and current source in circuit, right? This is what you need to do. Now tell me, Anand, is there any independent voltage source or current source in this circuit? Can you see any voltage source or current source in this circuit? Anand, can you see any in? Right,
Yes, sir.
go
Yes,
ahead.
sir.
What is the voltage source in this circuit? What is the
36.
voltage? 36. Is it dependent or is it independent?
Dep
Is it
Independent.
independent, right? So it's independent because its value is not, it's
Changing.
independent because its value is not depending upon anything, right? It's 36 and it's fixed quantity, right? So it's an independent voltage source. So what you need to do is you need to short it, right? When you are figuring the RTH value. So just let me short it, and then the equivalent circuit will become something like this. Correct, guys? Correct? So
I think 8, sir. 8 ampere. I got the answer.
now don't go there. Let me just proceed step by step. So uh, you have shorted the voltage source, right? And then you need to figure out what is the effective Thevenin's impedance looking from this point, right? Or from this point rather. So it's very evident that like these two circuits are coming in parallel, and it's now very easy to figure things out, right? So this circuit can be further reduced to like so 6 and 3 are coming in parallel, and from here 6 and 3 are coming in parallel, and both of these are connected something like this. Correct? Correct?
Yes, sir. Yes.
So 6 and 3 is coming in parallel, so you can write it as 6 into 3 divided by 9, that is 2, and 2 plus 2 is 4. So 4 ohm is the equivalent resistance, right?
Right.
And the voltage across these two nodes now you need to determine, right? So the voltage
Right.
can be determined using any of the methods which we have learned till now. So uh, if this circuit is open circuit, then the current which will be flowing in these two parallel paths, like you can determine, right? So 36 divided by 9 will be the current flowing here, correct? So 4 ampere current would be flowing, and similarly 4 ampere current would be flowing here. Now this voltage will be 36 volt. So 36 minus 4 into 3 will be the potential at this point. So uh, 36 minus 12 is 24, right? So this point is 24 volts, and 36 minus 6 into what was the current here? 4 amperes, right? So 36 minus 6 ohm into 4 is 12, right? So this voltage is 24, this voltage is 12. So the effective threshold, effective Thevenin's voltage will be equal to 24 minus 12, that is 12. And the Thevenin's resistance will be equal to, we have calculated as at 4 ohms, right? So 12 divided by 4 is 3. Okay, something went wrong. 4 ohm, and this is 36 minus 9 6 the 9 4 is 36, 4 amperes, 4 into 3 is 12, 36 minus 12 is 24, 36 minus 24 is 12. So 12 volts, 12 volt is the difference. Okay. I got it. So this is 12 volts. Okay, I have forgotten to add this particular term. So this is 12 volts, and then the RTH value we have calculated it to be 4 ohms, right? And this is 2 ohms which we have calculated, which is given in the question. So the current will be equal to 12 divided by 4 plus 2, that is equals to 2 amperes. Okay, so yeah, I've made so I'm hoping that you guys have understood it. I needlessly complicated the question, but I'm hoping that you guys have understood the question, right? So what you had to do was you have to figure out the Thevenin's voltage across the 2 ohm resistance, right? So that we have figured out as 12 volts. You have to figure out the Thevenin's equivalent resistance across these 2 points, so that we have figured it out as 4 ohms, right? And then you need to divide the Thevenin's voltage divided by total resistance to figure out the total value of current. So I'm hoping that you guys have understood it, right? So let me go forward. So the value of resistance R in the circuit is varied in such a manner that the dissipation in the 8 ohm resistance is maximum. So the dissipation in 8 ohm has to be maximum, right? This is what it is saying. So let me reduce the circuit before I proceed forward. So these two circuits are in parallel, right? So I can write this circuit as 12 volt, and this is resistance R. This is 18 ohms. This is 9 into 18 divided by 27. So 6. So 6 ohms, right? And this is 8. Okay. So you have 8 ohms with you, and you have 6 here with you, right? Uh, Tell me, guys, like what will be the current flowing in the circuit? It will be equal to 12 divided by uh, 6 plus 8, 14, right? Plus the equivalent value of this thing is equals to I equivalent. Correct? Correct?
Correct.
Correct. So what you need to figure out here is that that the power dissipated in the 8 ohm is maximum, right? So when will the power be maximum in 8 ohm? It will be when I square into 8 ohm, I in the 8 ohm resistance into square into 8 ohms is maximum, right? This is what the question is asking you. Figure out when this particular thing is maximum, right? And I know that the current which is flowing in this I8, like I've labeled the current flowing into the 8 ohm resistance as I8, right? So the current flowing in the 8 ohm resistance is maximum when this particular thing is maximum. Correct, because this is the equivalent current which will be flowing into the 8 ohm. Agreed? Agreed, guys? So here, if you see here, these two things are coming in parallel. This is coming in series. I have added I have summed the series thing, and with this particular element, right? And then I have divided it by 12, right? So the equivalent current is given by this, and this is nothing but I8, right? So I'm asking you when this is going to be maximum, when this is going to be minimum, right? When this denominator is going to be minimum, then the overall value is going to be maximum, right?
Right, right.
Right. So when is this denominator going to be a minimum? When the RE value is minimum, correct?
Yes. Yes.
But when is this RE value going to be minimum? What is RE? RE is nothing but R into 18 divided by R plus 18, correct?
Yes.
So when is this going to be minimum? When R is equals to 0? That is the minimum value you can have. Agreed. At R equals to 0, the R effective value will be equal to 0, because 0 into anything is 0, right?
Yes.
I'm hoping you are understanding, right?
Yes.
So if R is equals to 0, then the power dissipation is going to be maximum. So this will be the condition of R. So it's asking you under what condition the power dissipation is going to be maximum. So R is equals to 0, the power dissipation is going to be maximum. So, which is not given in the answer, and therefore the answer is D here. So the actual answer is R is equals to 0. So I'm hoping you understood it, right? Any confusions in this solution? Did you understand? Let me ask, Sharad, did you understand?
Yes, yes, sir.
Okay, Anand, did you understand? Anand, you can unmute yourself and say, did you understand? Okay, so for some reason he is not able to respond. Okay, so it's 9:30. So I think I'll end this presentation now. The remaining, there are 6 questions, there are 12 questions actually in this particular assignment. I've covered the first 6. The remaining 6 will be covered in the next 1 hour by my a colleague in the next subsequent addressal. So you can join her lecture, and then she will be covering the next 6, right? So I'm stopping the presentation now. Thank you guys for joining in, and have a good day.